One person who knows all about tethers in space is physicist Les Johnson, and he works at NASA Marshall Space Flight Center.
Thanks, Van. We're testing a new kind of propulsion system for space that doesn't need any rocket engines or fuel. Instead, it'll use the Earth's magnetic field to help push or pull on the spacecraft.
All magnetic objects form invisible lines of force that extend between the poles of the object. A magnetic field is the space around a magnet where you feel its force. Magnetic field lines extend and radiate between the Earth's north and south poles and between the poles of the magnet.
Basically, the Earth's magnetic field works with a special type of wire or conductor called an electrodynamic tether to push or pull on the object. The electrons that make up the electric current flowing through the conductor will experience a force when they move through a magnetic field like the Earth's. Since they're trapped in the conducting wire tether, the force will be applied to the tether and whatever is attached to it. Depending upon the direction in which the current is flowing, this force can be a push or a pull, either lowering or raising a spacecraft's orbit.
So the direction of the current determines whether it's pushing or pulling.
And the more current, the more force.
Right. In fact, NASA Marshall is working on a project called ProSEDS, which uses the Earth's magnetic field to push or pull on the attached tether. When the tether moves, so does the spacecraft.
Les, ProSEDS is an acronym, right? What does it stand for?
ProSEDS stands for Propulsive Small Expendable Deployer System. Space exploration is limited largely by the cost of launching payloads. Finding a cheaper way to explore space is always very important to us. Typically, a rocket will place its payload into low Earth orbit, and from there, propellant-fueled thrusters have to boost it to a higher altitude. ProSEDS is one experiment that focuses on the technology to cut the expense of placing a payload into its final orbit.
Sounds like ProSEDS can be a nice alternative to using rocket engines and lots of fuel.
Absolutely. Electrodynamic tethers could one day be used as a cheap, lightweight, and reliable way to remove space junk from orbit, keep the International Space Station in orbit, and even power missions at other planets.
Wow, this can get us to other planets?
Tethers offer us unlimited possibilities, Van. That's why I'm all charged up about this project.
There are several nations that want to build solar farms in space, which basically is to place a series of thousands of solar panels in space that collect the energy of the sun 24/7. Then said energy will be sent to Earth through microwave, or by means of laser. In turn on Earth there should be a huge satellite dish that collects said energy from the solar farm and transforms it into AC current. Here comes my theoretical proposal. What would happen if this satellite dish and the structure in space both send energy? This energy must have as its main characteristic that, in its concentrated light beam, favors the flow of electrons. So that the platform that is tied with hundreds of electrodynamic tethers can lift said platform and raise it without the use of cables or structures. Just like a magic trick. But it's the electrons flowing through the electrodynamic tethers that pull the platform out into space. Description of structures on land. Power plant. Storage building and delivery of materials to space. Walkway from the building to the platform. Underground satellite dish. 500 meters in diameter. Platform. In this example I have simulated the energy beam, or energy tunnel, in green color and the flow of electrons in red color. For the moment of levitating the platform into space, the satellite dishes at both ends, the one located on the ground and the one in the geosynchronous orbit, send this enormous energy beam. Within this energy beam, or tunnel of energy, the flow of electrons must flow with greater intensity than in the magnetosphere, causing the electrodynamic tethers to tense, and depending on the direction of the electrons they will pull the platform towards space. Once in space, at the indicated distance, the change of the flow of electrons in the electrodynamic tethers that were previously pulling the structure towards space will change and start pulling towards the Earth, to the opposite side, so that safely they will slow down the platform as it approaches the geosynchronous station. Once the platform arrives, it will first pass through the satellite dish and then it will reach the station level. There then the autonomous robots will be able to unload or deposit the merchandise coming from Earth to space or from space to Earth. This space station is supplied with a series of solar panels that feed it to be able to send the energy beam towards the Earth. And in the case given that here on Earth it cannot happen, either, because gravity is very intense here, the next question would be, could this system develop on the Moon or Mars? And not only that, could this system drive unmanned ships between planets? And tens of thousands of kilometers in a geosynchronous orbit of the Moon, there would be its counterpart, the station, near the Earth that receives the platform from the Moon. I am convinced that this is what Mr. Johnson means when he says that electrodynamic tethers can take us to other planets. Within a beam of concentrated energy that extends hundreds of thousands of kilometers into space. The ship adjusts the flow of electrons in the electrodynamic tethers, so that they pull the ship without the ship having to use fuel to move forward and move between the planets. Even with the same technology, small asteroids could be captured, diverted from their trajectory and redirected to a safe orbit for later mining.